Okay, so just like arrays, vector elements are stored in contiguous memory sections, that is one after another in memory, in the same memory block. But okay, just like this. Let's say we have a vector of 1, 2, 3, 4, 5, and I want to store it in memory. Like the way they arrange the memory is, let's just like we pictured in our array video, our memory. These are block. This is like a memory block. All these elements will be in. This is like the index 0, 1, 2, 3, 4, 5. So the elements will be 1, 2, 3, 4, 5. So this is, if you get the size of our array, this is the size as 5 elements. But if you try to get the fifth element, I'll tell you it doesn't, like, it will give you, you have to access it with the index 4. So you know that you can add an element. When you add a new element, it adds it immediately after this. So let's say add 20, so here will be 20 to be added immediately after this. So elements are stored just like an array, one after the other. But the difference between the vector and array is that you cannot add an element to an array, but you can add to a vector. And then you can decide to like erase these elements. And then when you remove this, everything shifts upwards. That is, this 3 will go into the space of 2, 4 will go into the space of 3. It's very costly. Deleting and insertion and deletion in arrays, in vectors, it's very costly, it's slow, because everything after this element will be shifted upwards. So that is why we only have what we call pop back. Well, I'll talk about that in code. We don't have pop front in array, in vectors. So that is basically a very high level overview. So these elements are stored one after another, just like boxes in a row. So here will be the 0th element, the second element, like that, just one after the other in memory, in the same memory block. So that is a high level view. Now we need to show how this is represented in code. Okay, these are remnants from our array video. We delete them. So to use vector, you need to include a library that will call vector, just exactly the way it sounds. Include, and that is what you need. You need that library to be able to work with vectors in C++. Oh, I shouldn't even have deleted. The declaring a vector is exactly like declaring. It's quite different though, but like it's kind of related. So you write the name vector, and within this angled brackets, you write the type. You don't need to specify size in vectors because the size is dynamic. Just write the type of the vector, and then let's see, we don't have any type of car, so just say string, and then the name of the collection, cars, and then that's basically it. So we have declared a vector with just a size that we don't care about. So now if we get the size is 0 right now because there's basically nothing in the array. So to insert an element in the array, not in the array, sorry, in the vector, we do vectors, no, sorry, car, that's the name of the vector, cars dot push back, pushback of. So that's the function for inserting an element, and then the okay, it has to be some kind of string. And to say the data type is string, let's say Mazda. Okay, so now we have two elements in this in this in this in these cars. So this is the same thing as doing cars is equal to Mazda and then Corolla. So they're basically the same thing. So there are some methods we need to talk about here to check. Okay, let me insert something else. Let me add maybe, let's say, cars dot push back. Let me add Benz. A Benz is very nice. All right. So we have currently three elements. So like if you try to get the size of this now, try to print the size of this vector. To get the size, you use the method called cars dot size. Basically just exactly the same thing. Cars dot size. So you can see that working with vector is very convenient because they give us a lot of methods, but like it's abstracted out. In array, you literally have to use the size of method in C++, but here just a cars dot size. So it's like kind of a class with a lot of methods they can work with. So if you print this out, let's say you compile it, I'm using the same array file, but like, yeah, they're brothers, so they can work together. Yeah, we can see that it's 3, give us 3, because we currently have, we have inserted 3 elements in the array. So to remove, okay, now to access elements in array, there are 2 ways. Either the traditional array way, that you say cars of in angle brackets, maybe up to. That's like the last element because there are just 3 elements in our massive, in our collection. So if you print this out, you print this out. Let me delete this out, it won't confuse us. If you print this out, to give us the last element that I added there, which is Benz. So you run this, yeah, and have our Benz. So this is the first way. This is the first way of accessing. Another way is cars dot at. This is usually preferred because it's more concise and like more readable. So cars dot at 2 will give us the same thing, exactly the same result. Compile, yeah, we have a Benz. So there are 2 ways. Either you use the traditional array way or you use the more convenient at. So assigning element. Let's say we want to change the Mazda to Corolla. So a Mazda is cars of 0. So we can do cars dot at 0 is equal to Corolla. Oh, no, let me print the at 2. Let me do the at 2 so you see like it actually changes it. I printed it before changing, and then let me print it. They say just copy the same line and print it after changing. Then you see difference. The terminal, compile, and then you can see Benz Corolla. It's not properly formatted here, but you can see Benz and then Corolla. So the Benz has changed to a Corolla. That's a downgrade. Nothing bad happens. Okay, another interesting method for vectors is the front and back. Let's say front, back. This method, it shows you front shows you the element at the front, the back shows you the element at the back. That's the last element. So let me just add more elements here. Let me say Benz, and then let me give a space, and then cars dot back. So this is like, it shows the front and the back. So I don't want to print it out. I just wanted to print it out in a line. So compile that. That is the element at the front. Let me lower this so I can see it. Yeah, this is Mazda and that's the Corolla. So removing an element from a vector is usually done through the method called pop back. So you can't pop front because of what I explained initially, because when you remove an element, everything under that element shifts up. So usually not encouraged. So an algorithm requires a lot of insertion and deletion, vector is not your data structure to use. So say pop back. So if we want to remove Corolla here now, okay, let me do it before I print the back and front. Let me say cars dot pop back, and then we do the same compilation and run. Yeah, we can see that yeah, Mazda is there, but like Bugatti is now the last element because we did pop back. Pop back removed our Corolla. Fortunately, we don't have Corolla in our garage anymore. That's basically it. So the last thing I want to talk about is looping through a vector. Since I said in array that the preferred way of looping is for each. Here now, the preferred way of looping is actually the proper complete for loop that has the size. So you say you start from 0, 0 is the fix, that's the index, and then I is less than the size, pass the size, and then plus I. And I want to print out pass dot at I. And then let me just add, okay, let me add a new line. Let me print everything in a line. Go for clear a terminal. Yeah, we can see that everything is printed here in a very clear way. Mazda Benz Bugatti Corolla. So that's how you iterate through elements of a vector. That's all we're going to talk about today about vectors. Vector is a very nice, convenient data structure that we use a lot, like is used a lot. Arrays are not even used that much. Vectors are like the go-to for almost everything. So learn this, practice using it. The methods are very nice, very simple, very convenient. So hit the like button, just like and subscribe, refer my channel to your friends. If you're enjoying the video, you also want your friends and family to enjoy too what we're enjoying. So yeah. Thanks for watching. See you in the next one.